Hello and welcome to another exam paper walkthrough. I'm switching my series around at the moment and I'm looking at some AQA papers. The school I'm working with at the moment is an AQA school, so I'm doing some AQA papers. This is taken from the June 18 2H paper. And like I said, this is an AQA past paper and we're only going to be looking at the even questions. So I've generated a half paper just based around the even questions from the June 2H paper. Um, in the description to this video, you will find a link to a Google Drive that will take you to a copy of this paper if you've not already got one. I would strongly recommend you do the paper either before watching the video or alongside the video to get the most out of it. I would also recommend some music on in the background. I've got an ear pod in, so I tend to have music when I'm recording the videos. I would recommend you have some when you're watching the videos. If you find this useful, please do subscribe if you like, and you will get the latest updates of when additional videos appear. Right, before I start going through the video, what I do want to just briefly discuss is the question level analysis for this paper. So I've got a lot of information on this paper, and a lot of it is going to be meaningless to you. But this is a breakdown of the question and the topics that are covered at each question. So if you're stuck on a particular question, you can use the chapter index to go straight to that question. But what's really quite useful, this is a paper out of 38. The national mean mark for this paper was or would have been 20.8, so sort of 21. And then we've got marks achieved by the grade. So in 2018, when all the students sat it, the students that got 9 would have got 35 on this paper, typically. Um, and so on. So you can find that useful just to kind of track your own progress and what grade you would have got on the paper. Right, let's begin. Okay, so this is a copy of the paper, and let's get straight into it. It is a calculator paper. For today's video, I'm going to be using my 991EX emulator. I'll try and record videos using other versions, but this is a nice emulator. All my others are kind of web emulators, which are a bit of a pain, not as easy to work with. But I'll talk you through any differences that may occur. Okay, so question one. Circle the number that is in standard form. So the key part of numbers in standard form is that the front number needs to be a number between 1 and 10. So because of that, I can get rid of this value and this value straight away because this one's less than 1 and this one is greater than 10. And then it needs to be times 10 to an integer power. It can be a negative integer power, but because this one is to the power of a half, it can't be that one, which leaves us with that one as our correct answer. Right, question 2. Work out 40% as work out 40 as a percentage of 10. So if I was doing this on a calculator, I would do 40 divided by 10 and then times by 100. So I'm looking at 400% there. Okay, question 6. The table shows information about the population of a city, and we've got population in 2001 and 2011, so 10 years later. Liam claims from 2011 to 2021, the population of the city will increase by the same percentage as in 2001 to 2011. Okay, he works out the population from increase from 2001 to 2011 is those figures subtracted, so 60,000. So the population in 2021 is going to be 480,000 plus 60,000, which is equal to 540,000. Does the population match this claim? So I'm going to say automatically no. But I'm going to state what he's done is he has increased by the same number, not the same percentage. So he has increased by the same number, not the same percentage. Right, that doesn't necessarily mean that he's going to be wrong though. because of the numbers, I can say that he's wrong, but I also want to show that. Right, so I'm going to work out what it should actually be. So let's show what he should have done. So he should have done 480,000 divided by 420,000 and then times that by 480,000. So that will tell us what the population should be if he was correct. So let's have a look at that. So 408, to be fair, I don't need to type the zeros. So there's nothing wrong with typing the zeros. I'm just suggesting that because they would cancel, it just seems a bit of a shame. And then I don't really need to do it. Times by 48, 480,000. So the population should be 448,857. I've said that wrong. 54,000. 448,571.428 dot dot dot. So that's what it should be. So if percentage increase is the same, the population would be 548,571. So is he correct? Does the population match his claim? No. We could have also worked out what percentage population that would have meant. That would be fine as well. Okay then, question 8. Theo starts with saving £18. James starts with no savings. Each week from now on, Theo will save £4.50 and Jamie will save £4. In how many weeks will Theo and Jamie have savings in the ratio of 15 to 8? Okay, so if we start by thinking of Theo's savings, so Theo's savings each week are going to be 18 plus 4.5 times the number of weeks, and Jamie's savings will just be 4 times the number of weeks. So we want to look when that ratio, the ratio of their savings, or in effect, when 18 plus 4.5n to the ratio of 4 to n will simplify down to 15 to 8. And we can do a bit of deductive logical reasoning here. So in 2 weeks' time, it would be 8 to 27, which isn't going to work. I'm going to go, I can kind of guess that 4 won't work either. That would be 12 to 1836, so that's not going to work. So let's go 6. 6 would be 24 to 18 plus 4.5 times 6 to 45, and that one will simplify down to 15 to 8. So my answer is, let's just put that weeks. My answer is 6 weeks. Right, question 10. So the volume of a sphere is 4/3 pi r cubed, where r is the radius. A container is a hemisphere of radius 30 centimeters. Sand fills the container at a rate of 400 centimeters cubed per minute. Does it take less than a quarter of an hour to fill the container? Does it take less than a quarter of an hour to fill the container? Right, so what I'm going to do is work out what the volume of the hemisphere would be. So the volume of the hemisphere is going to be equal to 4/3. Actually, I'll put divide by 2 in a second. Times by pi, times by, and we are going to keep working in centimetres, 30 squared, cubed, sorry. And then we want to divide that by 2, times by a half. So that's going to give me 4/6, which is the same as 2/3. So I'm going to jump straight to 2/3. 2/3 times by pi times by 30 squared, which is going to be 27 with 3 zeros. Let's just double check that. 30 cubed. Yep. And to be fair, we can divide that by 3 and then times that by 2. So we're actually after a total volume. The volume of the hemisphere would be 18,000 centimeters cubed. Right, the next thing I'm going to say is if it fills at a rate of 4,000 centimeter cube per minute, does it take less than a quarter of an hour to fill the container? So a quarter of an hour is going to be 15 minutes, so 60 divided by 15, sorry, 60 divided by 4. That's a quarter of an hour times by 400. So that will tell us the volume that would be filled in 15 minutes, which is going to be divided by 400. So that would be 6 with 3 zeros. And what have I done? I've missed a 0 out there, and I've actually missed pi out here. So let me just adjust that. That would be pi centimeters cubed. And that would be centimeters cubed. Right now, these look drastically out, but I've not actually done this times by pi. So shift pi. And I want the decimal version. So 56548.667 ... So that's the volume of a third, of the hemisphere. That's the amount of volume that would be filled. So we are looking at, would it fill? Yes. So let me just say yes. And I'll do it here as well. Yes, as 56,000, I don't want the comma, 56,548.66 ... is smaller than 60,000. And if you've done this slightly differently, so I did this kind of as 2 stages. I could have carried on working this through to say if I divide that by 4,000, that will give me the number of minutes that it would take to fill, and that's absolutely fine. I think that's probably the way I've done it there is slightly quicker, but you would still pick up all the marks. Okay, question 12. A straight line is drawn on a centimetre grid. Faye assumes that the scale is 1 centimetre to 1 unit. Use her assumption to work out the gradient of the grid. So we're told that this is a centimetre grid. This might be a slightly confusion. My year 11s, I gave them these printed on A5, so these would have only been half a centimetre, but it does say that you are to assume that this is a centimetre grid. Right, so to work out the gradient, we need to know the steepness of the line. The easiest way is to take a right angle triangle where we've got a nice opportunity to, and you can do a smaller one than this. Typically, I tend to use the bigger triangle as possible, but this one is clearly going through distinct points. The rise, so this is the change in y-axis has gone up by 4, and the change in x has gone 2, 4, 6, 8. So the gradient is going to be equal to 4 divided by 8. So the gradient is going to be a half. Right, part B. In fact, the scale is 1 centimetre to 2 units. Which of these statements will be correct? So 1 centimetre to 2 units, it doesn't really affect because that would actually mean that that's 8 divided by 16, so it wouldn't change anything. So the answer to part A is too big. The answer to part A stays the same. Okay, right. Question 14. What's that message coming in? Question 14. The scale drawing represents a garden. Water from a sprinkler P reaches up to 20 meters from P. Water from the sprinkler at Q reaches 25 meters from Q. Right. Is this going to be draw the loci? Using a pair of compass, show the region of water from both sprinklers reaches. Okay, so I'm going to actually just take this image into a different format, just so I can kind of show this a little bit better. Okay, so hopefully this will be, I'll be able to do this a little bit better with this. Right, so I can't do this as well as I was hoping, so I've lost a tool. So what I want to do is use my protractor to draw from here. If we're using a scale of 1 to 5 1 square represents 5 meters. I want to put a circle that's 4 by 4 by 4. I can't do that really well as I wanted to here, but what I'm going to do is I'm hoping that I can adjust this. Right, that's not particularly great. Right, so there I've got a 4 by 4 by 4 circle. You should draw it using your compass. And for the other one, I want a 5 by 5 by 5, 2, 4, which just about fits. Right, so using my compass, I'm going to do the same again. I'm just going to put a circle in. Right, so um, so 2, 4, 5, 2, 4, 5, 2, 4, 5. So that would be my 2 circles. Show the region that water from both sprinklers can reach. So the region that both would reach, I'm going to label it with an R. So they would show the region that both sprinklers would reach. So that would be the region that both would reach. Obviously, you'll have to draw that with a compass, but your diagram should look pretty similar to that. Okay. Right. Let's get back to. Okay, question 16. Some concrete has a volume of 3.8 meters cubed. The density of concrete is 2,400 kilograms per meter cubed. Work out the mass of the concrete. So the first thing that I'm thinking about is, have we got constant units? And we have, they're both dealing with meters cubed, which means that our mass is going to be, the mass that we worked out will be in kilograms. So density is equal to mass divided by volume. If you can't remember the formula, the unit itself gives you that really. Kilograms is a measure of mass, divided by meters cubed is a measure of volume. So if we want the mass, if we rearrange that, then mass is going to be equal to density times by volume. So we're looking at 2,400 times by 3.8. So 2,400 times by 3.8 is going to give us 9,120 kilograms. So 9,120 kilograms. Right, part B. 3.8 meter cubed of concrete is made into the shape of a cylinder. The base of the cylinder has a radius of 0.5 meters. Work out the height. Okay, this is kind of a little bit of rearranging. So the volume of a cylinder is going to be equal to the area of the circle, which would be pi r squared, times by the height. We want to work out the height though, so rearranging that would give us that the height is going to be equal to the volume divided by pi r squared. So 3.8 divided by pi times by 0.5 squared. And not set it out well, shouldn't really have two equals on the same line, but it's just to save myself a bit of space. So we'll type it in just like this on our calculator. We've shown what we're typing in, so we don't need to work it out as stages, provided we do it correctly. 0.5 squared. Double check that what I've typed in matches. So 3.8 is the volume, and the base is 0.5 meters, and that is definitely the radius. Okay, so we should have a height of 4.838 3 dot dot dot. So I'm going to give my answer. So I'm going to give my answer to, if we look, so we've got this to two significant figures. We've got this to one significant figure. I always either like to go one more significant figure or one more decimal place, and both, that would be the same for both really. So I'm going to go 4.84 meters. Okay, question 18. The solution of 3 to the power x is equal to 300 lies between two consecutive integers. Work out the two integers. Okay, so for this, in effect, we want to go 3 equals, and then we want to do answer times 3, and then count how many times we have to press it. So if I go 3 equals, and then times by 3, so that would be squared, cubed, to the power 4, to the power 5, to the power 6, so it's going to be between 5 and 6. But just to show that, we will go 3 to the power 5 equals, and 3 to the power 6 equals. And we've got that on 729. And then if I go backwards and divide by 3, that was my last one, 243. Okay, question 20 then. Here is an inflatable swimming pool. Here is an inflatable swimming pool with dimensions in centimeters. So we've got A, we've got B. The volume of the ring V cubed is given by V is equal to 0.25 pi times by B minus A all squared times by B plus A. Work out the volume when A is equal to 20 and B is equal to 30, giving your answer to three significant figures. Okay, so this to me just looks like a substitution question. So what's throwing me slightly is this is arguably a difference of 2 squares to a point, and I feel like we should do something with that, but it doesn't. I can't see it being a benefit to do anything with that. It just seems like a substitution question. So B minus A would be 30 minus 20 squared times by B plus A, so 20 plus 30. And even though I could do both of these in my head, I'm going to type it in exactly as it appears. Times by shift pi squared. Not exactly, I'm going to put a few more multiplication signs in. So 30 minus 20 squared times by 20 plus 30. Double check I've typed that incorrectly. Blah, 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 blah. Okay. So that gives me 12337.0055 dot 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 dot. So to three significant figures, that's my third significant figure. So to round correctly to that, that is closer to a 3 than it is a 4, so that would be 12300. Okay, question 22. A circular centre O passes through 5, 0. Okay, what is the equation of this circle? For an equation that passes through the origin, the equation for a circle would be x squared plus y squared is equal to r squared. And the radius of the circle would be 5. So we're looking for this one. And question 24. A tank is a cuboid measuring 50 by 35 by 20. All lengths are to the nearest centimetre. A container has a capacity of exactly 34 litres. 1 litre is 1,000 centimetres cubed. Which has the greater capacity, the tank, the container, or you cannot tell? Okay, so we need to work out the volume of the container. So the way I'm going to do that is 50 times by 35 to the nearest centimetre. Right. Okay, right, interesting. Okay, so realistically, what I actually need to do is the minimum and the maximum volume of the tank, and then compare that to 34 litres. So to do that, if it's been measured 50 to the nearest centimetre, the smallest that could be then is 49.5 times by, and I'm going to kind of do this in 2 stages, and the biggest that could be would be 50.5 times, so this is going to be the min, and this is going to be the max. Right, multiplied by 35 centimetres, the minimum that could be then would be 34.5, and the maximum that could be would be 35.5. And then 20 centimetres, the minimum that could be would be 19.5, and the maximum that could be would be 20.5. Right, that's going to give it me in terms of centimetres cubed, so I'm going to divide both of them by 1,000. Okay, so the minimum value then is going to be equal to, so the min would be equal to 49.5 multiplied by 34.5 multiplied by 19.5, and I'm dividing that by 1,000, and that one is less than the capacity. So 33.301 dot dot dot. And the maximum that could be then, let's just change these numbers, save typing it all in again. 50, 35, and 20. That's going to be nice. So that's going to be 36.751 dot dot dot. So as 34 is in between, it means that we cannot tell. Let's just show that those are litres. And as the minimum value, is less than 34 litres, which is less than the maximum value. That just explains it a little bit better. Right, question 26. Curve has the equation y is equal to 4x squared plus 5x plus 3. A line has the equation y is equal to x plus 2. Show that the curve and the line have exactly one point of intersection. Do not use a graphical method. Okay, so we're going to attempt to use a simultaneous equation where one is quadratic and one is linear. Okay, and so I'm going to say, call that equation 1 and call that equation 2. So I'm going to put them together. So I'm going to say that 4x cubed, 4x squared plus 5x plus 3 is equal to x plus 2. Because they're both equal to y, I've just said that they're equal to each other. Now if I take everything over to the left-hand side, that would give me 4x squared plus 4x plus 1 is equal to 0. And then technically, if we've got anybody particularly strong, you could look at the discriminant of this using the quadratic equation. That's more of an A-level skill though, so I will avoid that. What we're going to do is factorise it, and that factorises really nicely actually. Some people might have spotted that straight away. So the only way to make it a 4x squared is by a 2x and an x. 2x and a 2x. Technically you could have 4x and 1x, but this one works because this is a squared term. So that would be plus 1 and plus 1. Then if you think about multiplying that out, that would give you 4x squared plus 2x gives you the 4x, and then plus 1. So that shows that 2x plus 1 squared is equal to 0. So the only solution to that is x would be equal to a half. So the curve has exactly 1 point of intersection. So technically that shows 1 point of intersection. I'm going to go slightly further and say only point would be a half, and if x is equal to a half, y would be equal to 2 and a half. There we go, so that's the only point of intersection. Okay, question 28, functions. So f of x is equal to 5 minus x, and g of x is equal to 3x plus 7. Simplify 2 lots f of 2x plus g of x minus 1. Okay, so let's first of all show what f of 2x would be. Would be equal to, so we put 2x instead of x into this, so that would be 5 minus 2x. And let's at the same time do g of x minus 1. So that would become 3 lots of 3x minus 1 plus 7, which would be equal to 9x minus 3 plus 7, which would be 9x plus 4. So we just need to add these together then. So 9x minus 2x would be 7x, and 5 plus 4 would be plus 9. Right, and again I've made a slight mistake here. Anyone spotted it? So the slight mistake I made was this is the g of 3x minus 1, so that shouldn't have been a 3 there. So let me just change the bits that are affected. Right, so that should have just been an x, so that would have been 3x minus 3, so that would have been 3x plus, right, so then minus 2x plus 3x would be x, and then 5 plus 4 would be 9, so that should be x plus 9. Right, solve g to the minus 1 of x is equal to 2x. Okay, so the way, not the way, but the most straightforward way of kind of showing this is if I call this function of x, instead of calling it g of x, I'm going to call it y for now. And this just speeds up my notation a little bit. So I'm going to rearrange this to make x the subject. So in effect, that's kind of, that will give me the inverse of what would I need to do to go backwards. So I'd need to minus 7 from both sides and then divide by 3. So y minus 7 divided by 3 would be equal to x. So I've now changed the subject. So that means that g to the minus 1 of x is equal to x minus 7 divided by 3. And we're told that's equal to 2x. So 2x is equal to x minus 7 all divided by 3. So multiply 3 by 3, that gives us 6x is equal to x minus 7. Take the x over to the other side, so 5x is equal to minus 7. So x would be equal to minus 7 over 5. So minus 7 over 5. And that's the end of the paper. Right, before I sign off, I'll bring up that grade distribution again. Okay, a reminder, the chapter index of this is all of the topics for each question, and the average grade boundaries or sort of grade boundaries for this paper is you can kind of, it doesn't work specifically because there's something to do with, it's only half a paper, so there's less exam fatigue, but they were looking at roughly 35 for a 9, 31, 30, 31 for an 8, and so on. I hope you found that useful. I'll be trying to release these videos every fortnight, so every 2 weeks. If you want to get an update as soon as those videos are released, please do subscribe if you like. Any comments, questions, or feedback, feel free to pop them into the chat, and I'll get back to you fairly quickly. Thanks again for watching, and I will see you soon.